For this problem, it says the distribution of red blood cell counts is different for men and women in a certain population. And part A is asking for what is the mean for women? If I go back to the question, it states that for women, the middle 95% have a red blood cell count between 3.7 and 4.8 million cells per microliter. Okay, so how do we find the middle or the mean of this normal distribution? What I'm going to do is, this is not really necessary for the problem, but just to illustrate what's going on, I'm going to look at a normal distribution and look at what it means to be the middle 95% of the data. So here, in StatCrunch, I opened up the normal calculator, and I'm going to click here where it says between. And you can use this to look at the middle 95% of the data. Like if you're working with a standard normal distribution, a mean of 0 and a standard deviation of 1, if I put in 0.95 here, that means the middle 95% of the data, it gives me this picture. The numbers are a bit off, but here's what it's trying to convey. They're saying this 3.7 represents the lower bound for the middle 95% of the data. And this 4.8 represents the upper bound for the middle 95% of the data. And we want to find the value that is directly between those. It's right in the middle. You can find that by taking the average of the lower and the upper bound. So really, I can do this in a calculator. So what I'm going to do is pull up a calculator and just find the average of those two numbers. So I'll bring that up here. I'll take 3.7, add it to 4.8. I get 8.5, and then I divide by 2. 4.25 is the number that is directly between those two numbers. All right, so let's enter 4.25 into the correct place here. There's 4 options. The one that makes the most sense is B. The mean is 4.25. And since the normal distribution is symmetric about the mean is right in the middle, which is the average of the boundary values. Okay, so that makes sense. Okay, but then it goes on. It says, find the standard deviation for this data. All right, so the standard deviation. Let's go back just, again, to look at the curve here. If we're looking at the middle 95% of the data. If you have the middle 95% of the data, that means you went 2 standard deviations to the right and 2 standard deviations to the left. That means from this lowest part to this highest part, you went a total of 4 standard deviations. So if we actually know this distance and divide it by 4, that'll give us the standard deviation. So how can we do that? 4.8 million is the upper bound. If I subtract off 3.7 in the lower bound, that's going to be this length. If I take that number and divide it by 4, that number will be my standard deviation. So I think we can, do this in a calculator as well. So bring this back up here. All right, so that was, okay, I take the larger of the two bounds, 4.8, and I subtract off 3.7. Okay, 1.1 is how far you're going from the lower to the upper bound of the middle 95% of the data. If you divide that by 4, this number here represents the standard deviation. It says to round it to 2 decimal places, which is 0.28. So I'll put that here. So again, going back to this curve here, we now have all the data necessary to actually look at the appropriate distribution. We figured out the mean was 4.25, and the standard deviation was 0.28, and we were wanting to look at the middle 95% of the data. Yeah, the middle is, at 4.25. This lower bound was 3.7. This upper bound was 4.8. And when you're collecting the middle 95% of the data, that means you're going 2 standard deviations to the right and 2 standard deviations to the left. And that's how we got this number of 0.28. But to complete this question, let's just fill in the rest here. I think I've pretty much stated it, but just to complete the problem. The empirical rule states that about 95% of the data falls within 2 standard deviations of the mean. That means you go 2 to the right and 2 to the left. And that means the middle 95% of values spans, well, that's a total of really 4 standard deviations. And the standard deviation is found by dividing the range of the middle 95% of the data by 4. Okay, that is it for this problem.